I am going to talk you through an ionic bond, and we'll talk NaCl, sodium chloride, or essentially table salt. So here's what I know. I know that I have sodium, it's number 11 on the periodic table, and chlorine, it's number 17 on the periodic table. So let's put some information out. Let's make sure we get this sorted out. I know that for sodium, it's going to have 11 protons. It's going to have 11 electrons, right there, electrically neutral as they occur naturally. And it's going to have, I take my 23 AMU minus 11, and I'm going to get 12 neutrons. So for sodium, when I draw this, I'm going to say that I've got 11 protons, and I'm going to have 12 neutrons in the nucleus. I know that my first electron shell, my electrons, first electron shell, 2 electrons, second, 8 electrons, third, 8 electrons, and the fourth, 18 electrons, right? These are the rules. These are the rules here. I have to obey these rules. This is what they want to get to be stable. Stable is good. They're going to react until they get stable. So I've got 2 electrons here. Remember, I had 11 total. So that means I'm going to have 8 electrons here. And that said, I still have, see, 8 and 2 is 10, but I have 11. So I'm going to have 1 electron just kind of hanging out here. Just kind of moseying along its way. And I'm going to write it over here. 1 electron. So there you have it for sodium. Well, now let's talk about chlorine. Chlorine is element number 17. So I'm going to draw it over here. It doesn't really matter where I draw it. I'm just drawing it to where I can show the bonding here taking place here. So information I know. So chlorine is going to have, let's see. So chlorine is going to have 17 protons, 17 electrons. 36 AMU minus 17 is going to show that it has 19 neutrons. So here's my information. I'm going to create structure out of that. So I'll try to keep it up here. There. Okay. So I've got 17 protons. I've got 19 neutrons go in the nucleus. I know that I have 2 electrons in my first shell, right? Bingo. I have, let's see, 8 electrons in my second shell. 8 electrons. Bingo. These are supposed to be check marks. Pretty weak. Third electron shell. Let's see. 8 and 2, 10, but I have 17. 17 to work with. So I only have 7. What is up with that? So you know what? You know what this sodium here says to the chlorine? It says, you know what? We got problems. We both want to react. I want to give one up, and you want to gain one. So how about I just kick this over to you? Right? I'm going to lose an electron. So if I go from being neutral to losing an electron, I'm going to end up slightly positive. And chlorine, electrically neutral, naturally occurring, is going to gain an electron. It's going to have a negative charge to it. And what I've just completed here is I've got sodium with a slightly positive charge. I've got chlorine with a slightly negative charge. And now I've got electrostatics, or electric forces of attraction, coming together due to the charges. And this is my ionic bond. It's a very weak attraction, but it's still nonetheless an attraction. So notice, sodium satisfies its electron rules. First electron shell, 2 electrons. Second shell, 8 electrons. It's happy. Happy, happy, joy, joy. And my chlorine says, you know what? I've got 2 electrons first shell, bingo. 8 electrons second shell, bango. It now has 8 electrons in its third shell, bongo. So now I have plus and minus. Electric force of attraction, that's what's going to hold it together. This is an example of an ionic bond.